verifying the equation of a line through 2 points. In this example, we were asked to find the equation of the line passing through the points -1, 3, and 2, 0. And the work here is not shown, but we found that the answer is y is equal to -x plus 2. So that's the slope-intercept form of the equation of the line passing through those 2 points, or at least we believe it is. What we want to do is see if we can verify that, check our answer. And what we're really going to do is kind of bring a number of different ideas together from other videos all into one place. 4 ideas specifically. We're going to look at verifying the answer numerically, verifying the answer numerically using variables and relational operators, verifying the answer using a table, and verifying the answer using a graph. Let's start with the first one, verifying the answer numerically. What we know is supposed to happen with this equation is if I take the x-coordinate from a point, let's say -1 in the point -1, 3, and plug it in for x, when we evaluate the right-hand side, we should end up with 3 for y. So let's try that. So what we need to do is take the opposite of x to begin with. So I'm going to type in the negative that we see in the equation, and then I'm going to replace x with -1, and I'm going to substitute in parentheses. This is a good habit to be into, and I think it makes the substitution clear. And sometimes in cases like this, it can help with the negative signs, because what we're really doing is taking the negative of -1, and then I'll add 2 to that. We'll press enter, and we do indeed get 3. So when x is -1, y is 3. We can repeat for the second point. In this case, we'll replace x with 2. So I'll type in negative. That's from the equation itself. Open up a parenthesis and substitute the 2. Close the parenthesis, and I'll add 2. We'll press enter, and we get an answer of 0, which is exactly the y-coordinate we expect. So this is a numerical check, where all we're doing is just doing the substitution directly in the calculation screen of the calculator. We also want to see if we can verify the answer numerically using variables and relational operators. So let's press clear. And the first thing I'm going to do is look at this first point, -1 and 3. I'm going to store -1 into the variable x and 3 into the variable y. So I'll type in -1, and then we'll press the store key. And I'll use my shortcut for x, which is the variable key here next to the alpha key. And I can press enter. And then I'm going to take 3 and store it into y. So I'll press 3, store, and then we'll use the alpha key and the 1 key to get the y, and I'll press enter. So now -1 is stored in x, 3 is stored in y. Now we're going to type in the equation exactly as it is shown here. Y is equal to -x plus 2. So we'll start with alpha and 1 to get the y. Then we'll use second and the math key to go into the test menu. That's where we find that equal sign. So we'll press 1. And we want that to be equal to -x plus 2. When we press enter, the calculator will assume y is 3, x is -1, and if this equation is true under those two substitutions, we'll get a 1 in return, in response. If it's false, we'll get a 0. So we press enter, and we get the 1 that we expect. We've already checked this, and we know that it's true. All right, we can repeat this again for the point 2, 0. I'm going to take 2 and store it into the x variable. I'm going to do both of these stores in one line. So I'm going to use the alpha key and the period key, the decimal key, to get a colon. And I'll take 0 and store it into y. And we get the y from pressing alpha and 1. And I'll press enter. All right, and now we need to enter this equation again, but we've already entered it once back up here. So if I press second and enter to go back to entries, the first thing I'll get is the immediately preceding entry. If I press it a second time, second, and enter, I'll go back to that previous entry. So I don't have to retype the whole thing. I can use that second entry idea, in this case twice, to get back to what I want. Press enter. Now it's going to evaluate for x equal to 2 and y equal for 0. And if the equation is true, we get a 1 back. And we know it's true, and we do end up getting the 1 back. So we're in good shape there. So that's the first two checks that we have, verifying the answer numerically and verifying the answer numerically, using variables and relational operators. Now let's look at verifying the answer using a table. All right, what we want to do is press the y equals key, and we're going to use y1. That's going to be equal to negative x plus 2. So we're going to type in negative x plus 2, and we'll enter that. So there's our equation. Y is equal to negative x plus 2, or in the calculator specifically y1, since we can do multiple equations. All right, and then we want to work with a table. So let's press second and window to go into the table set screen first. All right, and we've got table start and delta table here. Let's not worry about those. Let's go and turn the independent to ask. What that's going to do is it's going to let us choose our own variables for x, and then it'll tell us what the corresponding value is for y. So what we need to do is cursor down twice to get to the auto, and then we'll cursor once to the right to get to the ask, and then we'll press enter so that ask is highlighted. All right. So once we have our table set up, we can press second and table, and now we don't have any values, but we can pick the values that we want. So we can type in, for instance, negative 1, and that comes back and tells us that y is 3. We can choose 2. Press enter, and that tells us that y is 0. And if we needed to, we could evaluate this function for any other value of y. Let's say that we needed to evaluate it for 7. We just type in 7 and enter, and the calculator will come back and tell us that we get negative 5. All right, this is potentially a nice way to graph equations using the table to get pairs of points. All right, we verified this 3 times now. We've got one way left. That's to verify the answer using a graph. All right, to graph something, we also start with the y equals menu, but in this case, we've already entered what we need. So we can go and set up the graph itself. So I'm going to choose to zoom to the standard window. You'll find throughout these videos I often like to start there. So I'll press the zoom key and choose option 6, which is zoom standard. Gives us that window that goes from negative 10 to positive 10 from left to right, and negative 10 to positive 10 from bottom to top. And there's a picture of our graph. If we want to verify those 2 points, make sure that they're both on the line, we can press the trace key first, and then we can pick the specific values that we're interested in. So I'll type in negative 1 and enter, and it comes back and tells me that when x is negative 1, y is 3, and it even shows me that point right there on the line. So that verifies the first point. We'll try the second point, 2, enter. When x is 2, y is 0, and we can see that there. And this visual also reinforces the fact that that's the x-intercept, which you may have already noticed from the fact that the y-coordinate was 0. So here are 4 different ways to find the equation of the line passing through 2 points once you've found that line. If you typed in an x value and didn't get the corresponding y value when you went through and do this, that's a good indication that the answer you've found, the equation you found, is incorrect, and you should go back and double check your steps. And if you think about it as you go through and do your work, really potentially throughout the entire semester, you'll find that a lot of these methods can be used for more than just linear equations and in more situations than just this.